where you are given a hydrocarbon name and you need to come up with its structural formula, then translate it into the condensed and the molecular formula. So here's the thing. Use your tables P and Q for this task. So step 1, circle the prefix in the hydrocarbon name. So when I take a look at this hydrocarbon name, it says pentane. So I am circling that, and I go to my table P. In table P, I find pent. So that means we have 5 carbons in the PC. So I'm just going to draw my 5 carbons. 1, 2, 3, 4, 5. Now, how do I link these carbons? Well, I notice that it ends in ANE, which means single bonds. Okay, so the suffix, link all of them with single bonds and look at that suffix. So here we go. These are all linked together with single bonds. Once when I put everything that's in this name into the structure, now I need to finalize it to make sure that all carbons have 4 bonds. Fill in remaining bonds with hydrogens. So my first carbon on the left, it only has 1 bond, so I'm going to add on 3 hydrogens. My second carbon, it has 2 bonds already, so I'm going to add 2 hydrogens to it to get my total to 4. My third carbon already has 2 bonds, so I'm going to add 2 hydrogens to it. My fourth carbon already has 2 bonds, so now I'm going to add 2 hydrogens to it. And my most right carbon, it only has 1 bond at this point, so I'm going to add 3 hydrogens to it to get the bond count up to 4. Okay, so the condensed structural formula. So carbon 1. So carbon 1, right there, so there's carbon 1, and attached to it directly, other than the parent chain bond, are 3 hydrogens. Carbon 2. Besides the parent chain green bonds, it has 2 hydrogens attached to it. Carbon 3, it also has 2 hydrogens attached to it. Carbon 4, it also has 2 carbons attached to it. And my last and final carbon 5, it has 3 hydrogens attached to it. Can't write and talk at the same time. So here is my condensed structural formula. Now the molecular. So the molecular is carbons followed by the hydrogens. So in this structure, it's pent. So we know that we have 5 carbons, and it's ane, so we know it's 2n plus 2. So 2 times 5 is 10, plus 2 gives us 12, and you can go back and count. 1, 2, 3, 4, 5, which makes 10, 11, 12. So here is our molecular. Looking at the next example, okay, I have a structure, propyne, so I'm going to circle prop because that's my table P information. That's where I always start, table P. And when I look at table P, next to prop, the N count is 3. So I'm going to put in 3 carbons. Now, I'm going to attach them because they're attached with at least a single bond. Okay? And now I notice, though, in this ending, there is an yne, Y-N-E, which means I have a triple bond. So I just work left to right, so I make this bond between carbon 1 and carbon 2, I make that a triple bond. So now I have my 3 carbons and I have 1 triple bond there. Now I need to finalize my structure to make sure every carbon has four bonds. So carbon number 1, okay, it already has 3 bonds, so it needs a fourth, so I'm going to add 1 hydrogen to it. Carbon number 2, it has 3 bonds here, plus 1 bond there, so it already has 4 bonds, no hydrogens added to it. And here we go. My third carbon, it only currently has 1 bond, so that means I need to add 3 hydrogens to it, so it ends up with a total of 4 bonds, or 4 total bonds. So the condensed structural. So here is carbon 1. So carbon 1, besides that triple bond it's part of, it only has 1 hydrogen attached to it. Carbon 2, it has no hydrogens attached to it. And then carbon 3, it has 3 hydrogens attached to it. So there's the condensed structural formula. The molecular. So prop means 3, so N is 3. And the ine means 2N minus 2, so 2 times 3 minus 2, 6, minus 2 means I have 4 H's if I use the formula. And if I actually go and count what I drew, 1, 2, 3, 4. Next example is butene. So take a look here. Okay. So I see my prefix, something from table T is but. So that's my table P information. And that means N equals 4. So I am going to draw my 4 carbons. Next step, all the carbons are linked together with at least single bonds. So I put those in to show that they are part of the same structure. But now I take a look at this and I see this ene, which means that there is a double bond in this structure. Now, what is a little bit new, and this is going to take practice, is this 2 here. It tells us the location of that double bond. So that is the location. So count your carbons left to right. So here is carbon 1, carbon 2, carbon 3, and carbon 4. What this means is that the double bond starts on carbon 2, and you work your way left to right. So carbon 1, carbon 2. This is where I need to put my double bond. So I have my 4 carbons. I have my double bond, and it extends from carbon 2 towards carbon 3. I have everything in the name, so now I need to finalize this structure with hydrogens. So my first carbon, it only currently has 1 bond, so I am going to add 3 hydrogens to it. Carbon 2 has 3 bonds total, 1 single and 1 double, making 3 bonds, so it only needs 1 H attached to it. Carbon 3 is part of the double, and on the other side it has a single, so it already has 3 bonds. So I'm going to put a hydrogen there. I like to change sides, it just makes it more readable. And then my 4th carbon, it has only 1 bond, so I need to attach 3 hydrogens to it. Coming up with the condensed structural. So carbon 1. Okay, carbon 1. It has 3 hydrogens attached to it. Carbon 2, it only has 1 H attached to it. Carbon 3 also only has 1 H attached to it. And carbon 4 has 3 hydrogens attached to it. So here is the condensed structural. The molecular formula. So here we go. So N equals 4, right? So we know we have 4 carbons, and it's an ene, so it's simply just 2 times 4, which means we have 8 hydrogens. So go through and check. 1, 2, 3, 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So our molecular matches back to our structure. Now, last example here. So take a look at this. This is named 1-butene. It has a very similar name to the structure up above. So it uses bute. So that's our table P. And that means N equals 4. So I need to draw my 4 carbons. And because they are part of the same molecule, they are all linked with at least single bonds, so showing that they're linked together. I take a look here, all right, and I see it's ENE, so that means that there is a double bond in the structure, but I just don't put it anywhere. That one out in front tells me where to put it. It tells me to put it on, starting on carbon 1. So left to right, carbon 1, 2, 3, 4. So my double bond starts off at carbon 1. So I need to put a double bond here. There's my double bond. So I have my 4 carbons. I have my double bond coming off of carbon 1. So I've put everything in the name. Now I need to finalize the structure with hydrogens. Carbon 1 has only has a double bond, 2 bonds. And here are the H's. Carbon 2 has 3, so it only gets 1 hydrogen. Carbon 3 only has 2 bonds, so we add 2 hydrogens to it. Add carbon 4 has only 1 bond, so we add 3 hydrogens to it. The condensed structural, carbon 1, it has 2 hydrogens, so we put CH2. Carbon 2 in the parent chain, it has 1 H attached to it. Carbon 3 in the parent chain, it has 2 H's attached to it. And carbon 4, it has 3 H's attached to it. The molecular. So bute, according to table P, N equals 4. But we have the ENE, so that means it is simply 2 times N, and that equals our ENE. So it's 2 times 4, which means we need to have 8 hydrogens in the structure.